In this video, we are going to discuss applied chemistry for CSC stream module 2. Okay, so these are the four questions that are most important, also the most repeated ones. So coming to the next question, coming to the first question, we have explained the types of organic memory devices by taking p-type and n-type semiconductor materials. So p-type means remember holes and n-type means you remember electrons. Okay, p-type organic semiconductors. Here we are using pentacene. Okay, pentacene. Pentacene is a organic molecule with pi conjugated system. It has holes as the main charge carriers. I told you, right? If it is written p-type, remember holes. So holes are the main charge carriers here, making it p-type semiconductor. It has 5 benzene rings fused together in a linear structure. See, in diagram you can notice here 5 benzene ring fused in a linear structure. This is a straight line, so it is a linear structure, and there are 5 benzene rings. Here at corners here you can see we have hydrogen atoms, which we do not point out as H. It is if we have not written anything, it is understood that these are hydrogen atoms. And further, we are going to replace it with fluorine. It exists in crystalline thin film form. This is exists in film crystal form, and these are rough surfaces. It has high hole mobility, meaning it effectively conducts positive charges. It conducts effectively a positive charges, but it is not stable. And this is used in display devices due to its ability to switch on and off state. Okay. So coming to the N-organic semiconductor. Here we are using pentacene, right? Here we are using pentacene, but in N-type we are using perifluoral pentacene. Okay, just it is formed by replacing hydrogen atoms with pentacene with fluorine atoms. Okay, here all I said right here there are hydrogen atoms, and it is not written. It is understood that we have hydrogen atoms. So in all places of hydrogen we are adding F, which is fluorine atoms. This makes it N-type organic semiconductor. Here in N-type organic semiconductors, electrons are the main charge carriers. In N-type, there are electrons as main charge carriers, and here in P-type, holes are the main charge carriers. These are used in high performance memory devices due to its stability and efficiency. Here, the stability is more in N-type compared to the P-type. Okay. Coming to the next question. What are memory devices? Explain the classification of electronic memory devices with example. So we know that memory devices are used to store data, right? Okay, so studying the definition, a memory device is a hardware component used to store data in electronic systems like computer, mobiles, and digital devices. So memory devices are used to store our data in computers and mobiles and memories. There are types of electronic memory devices. There are mainly four types, which are transistor type memory, capacitor type memory, capacitor type memory, and resistor type memory and charge transfer memory. So let's study all four of these. Transistor type memory. These are made up of p-type and n-type semiconductors, as we discussed in the previous question. These are silicon-based transistor. Transistor means it is a switch, which can be on and off. On means it will indicate 1, for off it will indicate 0. So the example is writing example is really important here, as the question itself mentioned memory device with example. So example for transistor type memory is RAM and flash memory. Okay. So the second type is capacitor. Here we are using capacitors to store electrical charge. So if the battery is the memory is charged, it will indicate 1. If it is discharged, it will indicate 0. So here the best example is DRAM. DRAM is dynamic RAM. Okay. So you need to draw this diagram. It carries marks. It will be having a good impression if you draw this diagram. Okay, on the invigilator. So next type is register type memory, which is also known as RAM. This uses metallic insulator metal structure. If it is having high resistance, which means off, it will indicate 0. Low resistance, which means on, it will indicate 1. Okay. Example is resistive RAM. RAM is like resistive type memory, resistive RAM. Okay. So coming to the last one, Charge transfer type memory. Here, donor and acceptor plays the main part. We are using donor and acceptor complexes to charge transfer. Conductivity depends on the ionic bending between D and A components. D means donor, A means acceptor. The example here is quantum dot memory, as we have discussed about this in the first module. Okay. Coming to the next question, question number 3. Mention any 4 properties and application of LCD displays. LCD means liquid crystal displays. Okay, here are the 4 properties. Liquid crystal can flow like a liquid due to loss of composition order. It can flow like a liquid due to loss of positional order. These are elongated and have some degree of rigidity. These are elongated and rigid. They have less orientational order. Here the orientational order is less. Transition from crystal solid to crystal solids to liquid crystals is caused due to change in temperature. The change in temperature causes it to move from crystal solids to liquid solids. Applications where all liquid crystals are used. So we are using liquid LCD displays in our daily life. These are used in watches, calculators, mobile phones, laptops, and computers. Also found in blood pressure instruments, digital thermometers, and TV channel indicators. These are also used in potentiometers, conductometers, and colorimeters. These are also used in optical shelters and 3D display technologies. So these are the 4 properties, and here these are the 4 applications. This question is repeated many more times, so it is better to study. And moving to the next question. Next question, mention any 4 properties and application of OLED. This question is very important, as also asked in the model question paper. Okay. OLED means nothing but organic light emitting diodes. So coming to the definition, OLEDs are thin film devices that emit light using organic molecules when an electric field is applied. So here the electric field is applied and the light is emitted using organic molecules. Okay. So coming to the properties, these are the 5 properties which are enough to get you the marks. So these are thin and flexible, suitable for curved displays. Which all curved displays you are seeing in monitors and like in watches and now recently in mobile phones, these are built using OLED. High contrast produces deep black and bright colors. This produces deep black. Okay, fast response, motion without lag. Here we can see the smooth motion without wide viewing angle, constant image quality from different angles. We get the constant image quality even if we view it from the 180 degree. Energy efficient, no backlight. Since no backlight is required, here the consumption of power is very low. Okay, coming to its applications. Applications are like I guess we use it in daily life. Flat panel TV screens, digital cameras, mobile phones, smart watches, curved monitors. Also, we can add it, and also in many year papers, this question is also asked. Mention any 4 properties and application of QLED. The difference between OLED and QLED is in OLED we are using organic molecules. In QLED we are using quantum dots. Okay, Q stands for quantum dots. So quantum light emitting diode. QLED uses quantum dots. See, I told you right. It uses quantum dots to emit light when excited by a light source or electric field. This uses quantum dots and the OLED uses organic molecules. The properties of these are these 6. Vibrant colors, it produces vibrant colors, energy efficient, high contrast, long lifespan compared to the OLED. Since OLED is using organic molecules, which means this will decrease the lifespan. You can write it in difference also. Long in QLED we get long lifespan, whereas in OLED we don't get long lifespan. Faster response, here we are also having faster response. These are flexible and used in bendable displays, but not as bendable as the OLEDs. Here the applications are pretty similar: flat TV panels, digital cameras, mobile phones, monitors. And the difference between QLED and OLED is the brightness. In QLED, we get approx 300 to 400 nits of brightness, whereas in QLED, we get 1000 to 4000 nits of brightness. So there is a mnemonic to remember these properties. Very easy handling looks fantastic and flexible. For very we similarly we are taking the first letters of every word. We get vibrant colors, energy efficient, high contrast, long lifespan, faster response, flexible display. Okay, these are the 5 questions which are enough for the module 2. If you need any of these PDF, just comment it down and I will be providing the link, or just DM me in the Instagram to get the PDF. Okay, thank you.